pullbox, also known as a pullbox or pull-up box, is generally larger than a junction box and is typically used for underground or overhead electrical applications. Its primary purpose is to provide access to wires for maintenance and repair. Pullboxes are usually made of metal or fiberglass to withstand the environmental conditions they are exposed to. Now let's discuss junction boxes. A junction box, sometimes referred to as an electrical box or outlet box, is typically smaller than a pullbox and is commonly used to connect and distribute electrical wires indoors. It encloses electrical connections, providing a safe and accessible location for wiring. Junction boxes are generally made of plastic or metal. The key differences lie in their size, location, purpose, and material. Firstly, size. Pullboxes are larger, whereas junction boxes are smaller. Secondly, location. Pullboxes are used underground or overhead, while junction boxes are used indoors. Thirdly, purpose. Pullboxes provide access to wires for maintenance, while junction boxes connect and distribute wires. And fourthly, material. Pullboxes are constructed using metal or fiberglass, while junction boxes are made of plastic or metal. Let's examine these differences in more detail. Considering size, the larger size of a pullbox is essential for accommodating the greater number of wires, and larger wire sizes often found in underground and overhead applications. The increased space also facilitates easier wire pulling and maintenance. In contrast, the smaller size of a junction box is suitable for the typically smaller wire sizes and fewer connections found in indoor wiring. Regarding location, the use of pullboxes in underground and overhead environments necessitates durable materials like metal or fiberglass that can withstand moisture, temperature variations, and physical stress. Indoor junction boxes, however, can utilize plastic or metal, as they are shielded from harsh environmental factors. Concerning purpose, the accessibility provided by pullboxes is crucial for performing maintenance tasks such as wire splicing, testing, and replacement. The enclosed nature of junction boxes ensures that electrical connections are protected from damage and accidental contact, enhancing safety. Let's consider some practical examples of when each type of box would be used. Imagine a scenario where a large number of electrical cables need to be routed through an underground conduit system. In this case, a pullbox would be installed at strategic intervals along the conduit run to facilitate the pulling of the cables. The pullbox would provide ample space for workers to grip and pull the cables, reducing the risk of damage. Now consider a situation where several electrical wires need to be connected to a light fixture in a residential building. In this case, a junction box would be installed in the ceiling or wall to house the wire connections. The junction box would provide a safe and accessible location for the wiring, preventing accidental contact and ensuring compliance with the electrical codes. It is important to select the appropriate type of box for each application to ensure the safety and reliability of the electrical system. Using a junction box in an underground environment, for instance, could lead to corrosion and failure of the connections due to moisture ingress. Similarly, using a pullbox indoors could be unnecessarily bulky and visually unappealing. In addition to the size, location, purpose, and material, there are other factors to consider when selecting a pullbox or a junction box. These factors include the number of wires that need to be accommodated, the wire size, the voltage and current rating of the circuit, and the environmental conditions. For example, if a circuit carries a high current, a larger box with a higher temperature rating may be required to prevent overheating. Similarly, if the box is located in a wet environment, a waterproof or water-resistant enclosure may be necessary to prevent moisture damage. To summarize, pullboxes are typically larger, used for underground or overhead applications, provide access for maintenance, and are made of metal or fiberglass. Junction boxes are smaller, used indoors, connect and distribute wires, and are typically made of plastic or metal. Understanding these differences is crucial for ensuring the safe and effective installation and maintenance of electrical systems. Let's delve deeper into the specific requirements for pullboxes and junction boxes according to electrical codes and standards. The National Electrical Code, or NEC, provides detailed guidelines for the installation and use of these boxes. For pullboxes, NEC Section 314.28 covers the requirements for sizing pullboxes, junction boxes, and conduit bodies. This section specifies the minimum dimensions of the box based on the size and number of conduits entering and exiting the box. The purpose of these requirements is to ensure that there is sufficient space within the box for the wires to be properly trained and connected, and to prevent overcrowding, which can lead to overheating and insulation damage. Specifically, NEC 314.28 A1 states that for straight pulls, the length of the pullbox shall not be less than 8 times the trade diameter of the largest raceway. This means that if you have a 4-inch conduit entering and exiting the pullbox in a straight line, the minimum length of the pullbox must be 32 inches. For angle or U-pulls, NEC 314.28 A2 specifies that the distance between each raceway entry inside the box and the opposite wall of the box shall not be less than 6 times the trade diameter of the largest raceway in a row. Additionally, the distance between raceway entries enclosing the same conductor shall not be less than 6 times the trade diameter of the largest raceway. These requirements ensure that there is adequate space for bending the wires within the box without damaging the insulation. For junction boxes, NEC Section 314.16 provides guidelines for calculating the number of conductors permitted in a box. This section specifies the maximum number of conductors, devices, and equipment that can be installed in a box based on its volume. The purpose of these requirements is to prevent overcrowding, which can lead to overheating, insulation damage, and difficulty in making connections. NEC 314.16 specifies that the volume of a box shall be sufficient for the number of conductors, devices, and equipment contained within the box. The volume of the box is typically marked on the box itself, and the number of conductors permitted is based on the wire size and the box volume. For example, a standard 4-inch by 4-inch by 1.5-inch square box has a volume of 21 cubic inches, according to NEC Table 314.16. This box can accommodate up to 7 number 12 American wire gauge or AUG conductors. In addition to the sizing and conductor fill requirements, the NEC also specifies requirements for the installation of pullboxes and junction boxes. NEC 314.23 covers the requirements for the supportive boxes, conduit bodies, and fittings. This section specifies that boxes shall be securely fastened in place and supported independently of the raceway. The purpose of these requirements is to prevent the box from being pulled loose from the wall or ceiling, which could damage the wiring and create a safety hazard. NEC 314.27 covers the requirements for outlet boxes used as the sole support for ceiling fans. This section specifies that outlet boxes used for this purpose shall be listed for fan support and shall be capable of supporting the weight of the fan. The purpose of these requirements is to prevent the fan from falling from the ceiling, which could cause serious injury. Furthermore, the NEC addresses the materials and construction of pullboxes and junction boxes. NEC 314.40 covers the requirements for the construction and marking of boxes, conduit bodies, and fittings. This section specifies that boxes shall be made of durable materials that are suitable for the environment in which they are installed. The boxes shall also be marked with the manufacturer's name or trademark, the voltage and current rating, and the volume of the box. The purpose of these requirements is to ensure that the boxes are of high quality and are suitable for their intended use. NEC 314.41 covers the requirements for the corrosion resistance of boxes, conduit bodies, and fittings. This section specifies that boxes installed in corrosive environment shall be made of corrosion-resistant materials or shall be protected by a corrosion-resistant coating. The purpose of these requirements is to prevent the boxes from corroding, which could compromise their structural integrity and create a safety hazard. In addition to the NEC, other standards, such as those published by underwriters' laboratories, also provide requirements for the construction and testing of pullboxes and junction boxes. The UL standards cover a wide range of safety and performance requirements, including those related to fire resistance, electrical insulation, and mechanical strength. Compliance with these standards is typically indicated by a UL listing mark on the box. When selecting a pullbox or junction box, it is essential to consider not only the size and conductor fill requirements but also the environmental conditions in which the box will be installed. For example, if the box will be installed in a wet location such as outdoors or in a bathroom, it should be listed as suitable for wet locations and should be constructed of corrosion-resistant materials. If the box will be installed in a hazardous location such as a paint booth or a grain elevator, it should be listed for use in that specific hazardous location and should meet the requirements of NEC Article 500 through 516, which cover hazardous locations. In addition to the general requirements for pullboxes and junction boxes, there are also specific requirements for boxes used in certain applications. For example, NEC 314.29 covers the requirements for boxes enclosing flush-mounted devices. This section specifies that the box shall be designed to securely support the device and shall provide adequate clearance for the device terminals. The purpose of these requirements is to ensure that the device is properly installed and that the connections are accessible for maintenance. NEC 314.30 covers the requirements for boxes installed in concrete or tile. This section specifies that the box shall be designed to be securely embedded in the concrete or tile and shall provide a watertight seal to prevent moisture from entering the box. The purpose of these requirements is to protect the wiring from moisture and damage. Understanding and complying with the NEC and other applicable standards is essential for ensuring the safe and reliable installation of pullboxes and junction boxes. Failure to comply with these requirements can result in electrical hazards such as short circuits, ground faults, and fires. It is always best to consult with a qualified electrician or electrical inspector if you have any questions about the proper selection and installation of these boxes. Let's shift our focus to the practical aspects of installing pullboxes and junction boxes. Proper installation techniques are critical for ensuring the long-term reliability and safety of the electrical system. Firstly, before beginning any electrical work, it is essential to de-energize the circuits at the main breaker or fuse panel. This will prevent accidental electric shock and ensure your safety. Always use a voltage tester to verify that the circuit is de-energized before proceeding. Secondly, select the appropriate size and type of box for the application, as discussed earlier. Consider the number of conductors, wire size, voltage, current, and environmental conditions. Thirdly, prepare the wires for connection by stripping the insulation to the appropriate length. Use a wire stripper tool to avoid nicking or damaging the conductors. The amount of insulation to strip will depend on the type of connector being used. Fourthly, make the wire connections using approved methods, such as wire connectors, soldering, or crimping. Ensure that all connections are tight and secure to prevent loose connections, which can cause overheating and voltage drop. When using wire connectors, select the appropriate size and type for the number and size of conductors being connected. Follow the manufacturer's instructions for proper installation. Fifthly, ground the box if required. Metal boxes must be grounded to provide a path for fault current in the event of a short circuit. Use a grounding screw and a grounding conductor to connect the box to the electrical system ground. Sixthly, neatly arrange the wires inside the box, ensuring that they are not overcrowded or tangled. Use wire ties or cable clamps to secure the wires and prevent them from being pulled loose. Follow the NEC guidelines for wire bending radius to avoid damaging the insulation. Seventhly, close the box with a cover or blank plate. Ensure that the cover is securely fastened to the box to prevent accidental contact with live wires. For outdoor installations, use a weatherproof cover to protect the wiring from moisture. Eighthly, label the box with the circuit number or other identifying information. This will make it easier to identify the circuit in the future and will assist with troubleshooting. Use a permanent marker or label maker to create clear and legible labels. Ninthly, inspect the installation to ensure that it complies with all applicable codes and standards. Check for loose connections, damaged wires, and improper grounding. If you are not comfortable performing the inspection yourself, hire a qualified electrician to do so. Tenderly energize the circuit and test the installation to ensure that it is working properly. Use a multimeter to verify the voltage and current at the box. Check for any signs of overheating or other problems. If you encounter any issues, de-energize the circuit and troubleshoot the problem before continuing. In addition to these general installation guidelines, there are also specific techniques for installing pull boxes and junction boxes in different types of construction. For example, when installing boxes in drywall, use drywall screws or anchors to secure the box to the wall studs or framing. When installing boxes in concrete, use concrete anchors or expansion bolts to secure the box to the concrete. When installing boxes in suspended ceilings, use hanger wires or ceiling clips to support the box from the ceiling grout. Always follow the manufacturer's instructions for installing boxes in specific types of construction. Furthermore, it is crucial to maintain pullboxes and junction boxes regularly to ensure their continued safe and reliable operation. Perform periodic inspections to check for loose connections, damaged wires, and corrosion. Tighten any loose connections and replace any damaged wires or connectors. Clean the inside of the box to remove any dust, dirt, or debris. Lubricate any moving parts such as hinges or latches to ensure smooth operation. For outdoor installations, inspect the box for water damage and repair any leaks or cracks. Apply corrosion-resistant coating to any exposed metal surfaces. By following these maintenance guidelines, you can extend the life of your pullboxes and junction boxes and prevent electrical hazards. In conclusion, understanding the differences between pullboxes and junction boxes, complying with the NEC and other applicable standards, and following proper installation and maintenance techniques are essential for ensuring the safe and reliable operation of electrical systems. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns.